Hi everyone, welcome to learn the algorithm with me together. Today let's take a look at the 645 set mismatch. And we will be given a set of integers s, which original contains all the numbers from 1 to n. And unfortunately, due to some error, one of the numbers in s got duplicated to another number in the set, which results in we will probably have two number of the same number and then miss another one. And now we need to find these two numbers. So for example, let's take a look at this. We will have like 1, 2, 2, 4. And obviously we can see that we have like 2, 2, and then we are missing 3. So we have to return the results is 2 and 3. And now I'm thinking like how we can find the duplicate numbers or the missing number. So first of all, for the duplicate one, usually we will use a set. What is the characteristics of a set? Like when we are putting a number into the set, we can make all the numbers are unique in the set, right? So for example, if we are traverse the whole array, then when we put every numbers into it, when we are going to the like these numbers on the index 3, we will definitely already set, okay, the set already contains it. So this one will be the duplicate one. We cannot do that. So this is the one way I'm thinking about how to solve, how we find the duplicate one. All right, and let's take the index to help us to understand which number I'm talking about. And but however, how I can find the missing one, because we cannot check the set already have it or not, right? And here's an interesting part, like because this number is from 1 to n, this should be like we have 1, 2, 3, 4 in this array originate, right? And which is just a contiguous numbers as our index. And sometimes we can use the index help us to find the duplicate one or the missing number. How it can help, for example, like if we are traverse to the, for example, number 4, right? So if you are pointing to the 4, we can probably fix the index if we have 4 and flip the number on that index as a negative number. Right, okay, now let's confirm another thing is, are all the numbers in this array are positive or negative? Because if it is have the negative or the positive number in the array, probably we cannot use this approach. And yeah, so the numbers in this array is all greater than 1 is good, because if the numbers are 0, it's also not help us, because when we flip the 0, and 0 cannot be flipped as a negative or positive number, but now we can do that. But of course the index, we don't have the index for, so probably we can use the current number -1 as the index, because it is starting from 1, right? We still have 1 -1, we still have the index 0. And now if we are encountered 4, and we will flip the numbers on the index 4 -1 equals to 3, and flip that number as negative number, like here as like -4. And of course, let's go back at beginning, but because usually what we do is from traverse from the left to right, right? And it means that if the numbers only occurs for one time, when we are flipped the numbers in the array, it will definitely become a negative number. But if the numbers occurs like twice or never occurs, that index won't be flipped. It will always be the positive number, right? So what we are doing is like, let's take a detailed step. Like when we are starting from this, the first letter, like one, the first number one, we will flip the index is 1 minus 1 is 0, so flip the number on the index 0 as a negative number, and then move to 2, and the 2, well, move the number on the index 2 minus 1 is equals to 1, make it as a negative number, and then move to next one, 2, and 2 still flip the numbers on the index 1, we'll make it as a positive again, and move to, as we say before, is 4, and it will be minus 4. All right, and now after we looping it, now we can start to go through this array again and to find which numbers are still positive. If it is positive, we will get its index. Like 1, we will go back to add 1, and it means that the number 2 is duplicate or missing. When we are moving to 2, and it will be, the number will be 2 plus 1 will be 3, right? And now we already know which is missing one or which is the duplicate one, and we'd love to know like what kind of the return value we need to return, right? We return, do we need to care about the order? If we don't care about the order, usually we'll return like the list, or but if we care about the order, like we will return like integer array or something. All right, so it requests us to return the integer array. Okay, and also we know we only have two numbers like this, and so we know the size of this integer, so we don't need the help of the list of array. Good. And the second one is, yeah, as I said, do we need to care about the order? Like, for example, if the first one is should be the duplicate number, or this the first one is the duplicate number, and the second one is the missing one. In these two examples, we cannot tell, and let's see, which result in repetition. And in the form of an array, it doesn't say that. Probably we have to test it later to see, do we need to care about like we return it as a ascending number? Because if we are returning as ascending number, just looping it, it will be definitely ascending numbers, right? Let's write circles. Like, of course, we will have like two loop the array, right? The first time is just flip the numbers. Now we will get the current number, right? Get the current number, and then flip the index, flip the number on the index, which is number minus 1, right? And then we start loop again, and then we need to find the positive number, add the positive number into the results, right? So this is how the idea how I solve this problem, and let's start the coding part. Right, and now of course we will, let's see, loop the array to flip the numbers and then loop the array to find the positive numbers. Alright, and now let's start it. Because we have to know the index, so we still use I, and starting from 0, and we add it before the length. So first we will get the numbers, and there's maybe a scenario is that we already flipped the numbers on that position when we are encounter it, right? And but if I just get the numbers like this, it may be a negative. So we have to ensure that it is a positive number, because when we are start to flipping it, the index cannot be a negative numbers, right? So now we are starting to flip it. We can times -1, and then we start to have the result. We only have the two numbers, obviously, and then start to loop again. We still care about index, so that's why we use the I, and starting from 0, numbers, length, I plus. Then if the numbers are greater than 0, what we can do, right, and we need the index to help us to put the put current number to the result 0, and the result index equals to the current number. No, we need the index plus 1, right? After that, we have to move the index, right, and then we return the result. Oh, we forget new. Alright, now we fail the case. Alright, so yeah, we are returning the result in a ascending number, but apparently it expects us like on the first position is the duplicate number, and the second position is the missing number. And how we can do that? How we can fix this? Let me see. Alright, so for the first loop, we already know which is the duplicate, because when we are seeing the numbers already negative, right? It means that it already occurs for one time, and now we see that again. So of course we can flip that numbers, right? Numbers, like if the numbers is already negative, it already the result on the first position will be these numbers, and then we don't have to flip it because it's a duplicate one. And if the rest of the numbers is positive, it means that it's just a missing one, right? Like let's see here. When we move to 2, and we'll flip it as a -2. And when we move to here, it already see, okay, you already flipped. I know you are the duplicate one, so we don't have to put it back. So when we are go through these numbers again, when we move to here, we know this is the only positive one. It means that this is the missing numbers. Missing number is we can get it from the index 2 plus 1, and it's the 3. So probably it will help us, so we don't have to flip it. Else we just, so if it is not the negative numbers, we can flip it. But if already negative number, we don't have to flip it. And here we don't have the index because we already add the duplicate number on the 0. Now we add it on the second position is the missing number, right? Now let's run again. numbers. Okay. Oh yeah, we have to initialize the result at the beginning now because we are starting to construct the result. Good. And let's see if we already passed all the cases. Looks good. It's really efficient, and yeah, the time complexity will be ln because for first loop is ln and the second loop is ln, and when we add it up it's just O2n. We can ignore the 2 and assume it's just on. And for the space complexity, because we don't use other data set to help us to find if it's duplicate or missing, and just a fixed site array, so it won't cost us a lot of memory. So yeah, this is how we are finding the duplicate number and the missing number without extra data sets. Hope you can learn it. Thank you.